Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're looking at the 2025 exam paper and we're looking at question 10, part B. So the question is, a particle is projected from a point P with initial speed u. After 6 seconds, its horizontal displacement and vertical displacement are 75 meters and 30 meters respectively. Calculate u. So I'm going to do this with two different ways. I'm going to use trigonometry, which may not be the first choice, but actually a lot of students will default to this method because of the way that they resolve their initial velocity. So I'll work it through with the trigonometry and then I'll show you a nice quick way that we don't have to use trigonometry. So let's set up our little table of what our VUAST is in both directions. So I've just put in straight away our acceleration because we know in our questions that they never change. So we're given an initial speed u. So let's resolve that. So if this is u, let's give it an angle. They haven't given it to us here. So let's give that theta. So that means it's breaking into two parts. That gives us u cos theta I and u, sorry, put that in the, well, not the wrong place, but not the right place. So u cos theta, and then this will be u sine theta. And then we know because there's no acceleration, that is why our Vx is the same. So then it gives us two displacements. So horizontal displacement, we're talking about the x direction, and vertical, we're talking about the y. That means this is my sx and this is my sy. So there's my 75 and there is my 30. And we know that happens after 6 seconds. So we're going to work with two directions and we're going to work with the same equation in both. We're going to work with S equals UT plus a half AT squared. So in the x direction, that formula becomes S, which is 75, is equal to U cos theta times 6 plus a half times 0, 6 squared. That all disappears and we get U cos theta is equal to 75 over 6. And then if we work in the y direction, we then have S, which is 30, is equal to U sine theta t, which is 6, plus a half times minus 9.8 times 6 squared. So what we can do here, there's a few different ways we can work it. I'm going to focus on getting the u sine, so let's do 6 u sine theta. So we're going to get the u sine theta on its own. So that's going to be 30, and then bringing this across, that's 176.4. And if I want to isolate just the u sine theta, totaling this divided by 6, we get 172 over 5. So we're going to work out the angle first. And to do that, we're going to use this little bit of trig, which is that tan theta is equal to sine divided by cos. So this is a nice little trick we can use anytime we have our vector broken down. So we see it here in projectiles. You might also see it in oblique collisions. So I'm going to do u sine theta divided by u cos theta, because those u's are just going to cancel out as well. So we have 172 over 5 all over 75 over 6. So when we work that out, we get tan theta is equal to 2.752, and that gives us our theta, which works out about 70 degrees. Now that I've got my 70 degrees, we can go back and we can work out our u. So I'm going to take this equation here. I'm going to bring it up where I have a bit of space, and I'm going to say u cos 70 is equal to 75 over 6. So u is equal to 75 over 6 divided by cos 70, and that works out as 36.6 meters per second. Now, you could, with that, you cos theta, we could have kind of worked with that in terms of a triangle and worked through. But honestly, one of the easiest ways to work is to just use that little trick with our tan. Let's look at a method now that doesn't use trigonometry. So a particle is projected from point P with initial speed u. After 6 seconds, its horizontal displacement and vertical displacement are 75 meters and 30 meters respectively. Calculate u. So let's fill in our table again. So we have our 75 meters in the horizontal direction after 6 seconds, and we've 30 meters in the y direction after 6 seconds. Now, the difference with this like no trig method is that we're not going to resolve our initial speed. We're going to treat the two components separately, yes, but we're not actually going to resolve them using sine and cos. I'm going to simply call this one x and this one y. Now, I'm going to do the same process as before. So I'm going to work with both of them, and it's going to be s is equal to ut plus a half at squared. In the x direction, that's going to give me s, which is 75, is equal to x times 6 plus a half a t squared. That's all gone. X is 75 divided by 6. And that gives us 75 divided by 6. And that gives us 12.5 meters per second. And then the y direction, we're going to do the same. And that's going to give us 30 equals y times 6 plus a half minus 9.8, 6 squared. That gives me 6y is equal to 30 minus, that gives me 0.5 by 9.8. And that gives us, so minus, and then we bring it over, it's going to be positive 176.4. Add those together, and then we get 6y is equal to 206.4. Divide both sides by 6, and we're left with y is equal to 34.4 meters per second. So what we have here is that's what we want, that's our u, but we've actually just worked out our x direction, which is 12.5, and our y direction, which is 34.4. So what we're going to do to get our answer for u is we're now going to find the magnitude. So if you think about it this way, we have u is equal to 12.5i plus 34.4j, and then we want the magnitude of that, which is the square root of 12.5 squared plus 34.4 squared, and that gives us our final answer for u as 36.6 meters per second. Now, you might argue that there is a little bit of trig in the sense that our magnitude formula is from Pythagoras, but most students will just have that magnitude formula. So I'm sticking to this no trig. So really what we're not getting involved in the angles, the sine and the cos. Now looking at this often is a much easier method for students, but it's not as obvious. Most students wouldn't necessarily go to this method. So if you are somebody who prefers not to see sine, cos or tan, then this is a nice method. It's a little bit quicker, because we're not finding the angle and we're going straight to just getting the thing we want. We're straight getting our u, but both methods, one is not going to delay you much more than the other.